In this video, we're going to look at some examples of the problems looking at our standard form for ellipse that we talked about in class. So the first thing we want to look at is if we have an ellipse already in standard form, let's determine how we can find the values of the center and the values of A, B, and C. Those are the things that we need to calculate either vertices, covertices, foci, and so forth. So the center is pretty easy. We know that we're always going to be able to find our value for HK, which is going to be our center, just by looking at our equation. We know that H is always going to be next to our X, and we know that K is always going to be next to our Y. So we know that looking at this, our value for H is going to be 1, and our value for K is going to be 1. So our center is at the point 1, 1. Now to find the values of A, B, and C, we need to remember the relationship. We know that in an ellipse, A squared is always larger than B squared. So this tells us that A squared has to be 49, therefore A has to be the square root of 49, or 7. And B squared has to be 4, and therefore the square root of that is going to make B 2. We also know that to find C, the relationship in an ellipse is that A squared minus B squared equals C squared. So if A squared is 49 and B squared is 4, that tells us that C squared is going to have to simply be 45. And if we take the square root of that, that will give us the square root of 45, which we know simplifies into the square root of 9 times the square root of 5. So 3 square root of 5 would be our value for C. Using those values of A, B, and C, we could find our vertices, covertices, and foci. Let's try this one. Again, we want to find the center and the values of A, B, and C. So we know our center is going to be at HK. What's our value for H here? Well, because it's just x squared, that tells us it's going to be 0. This is like saying x minus 0 or x plus 0 squared. Our value for K is going to be what? Negative 2. Now, we know to find our values for A, B, and C, we know that in an ellipse, A squared is greater than B squared. So in this case, 9 is going to be our A squared, and 1 is going to be our B squared. So that means our value for A is going to be the square root of 9, which is 3, and B is going to be our square root of 1, which is 1. We also know that A squared minus B squared is going to give us C squared. So 9 minus 1 is going to give us C squared. So the square root of 8, or 2 square root of 2, is going to be my value for C. Now let's get into the standard form of the ellipse if it's not already in the form. One of the things we notice about the standard form of the ellipse is besides having the two quantities squared, it was always equal to the value of 1. So if we have any value other than 1 here, we need to make sure that the final step is to divide by whatever this value is to get it to be 1. We also notice that we've already completed the square because we already have the quantity squared. So all I have to do to get this into standard form is simply divide everything by 225. Then we'll have our equation equal to 1. Now, depending on whether this number is equally divisible or not, we may have a value or we may have a fraction in here. Well, fortunately, 9 times 25 is 225, so this works out very nicely. So in this case, it's going to be x minus 1 quantity squared over 25 plus y plus 2 quantity squared over 9 equals 1. If when we were dividing these values did not work out to be nice numbers, that's okay. We can go ahead and put fractions in there, but we do want to make sure that we don't have anything in front of the x quantity or the y quantity here. So if you don't have an exact value, put the fraction, the entire fraction, in the denominator. So this tells us that A squared is going to be 25 and B squared is going to be 9, and we can use that to find our values of A, B, and C. And of course our center is already kind of in standard form, so it would be 1, negative 2. Now, this was a nice easy problem because it was already kind of done to complete the square. What if it's not already done like this? Well, it's very similar to our problem that we did for the circles. If you know how to complete the square for circles, you know how to complete the square for an ellipse. The exception is, in a circle it was nice because we had a radius which stayed the same throughout. In an ellipse we've got a major axis and a minor axis. So unfortunately, dividing out by a value to start with won't help us. We notice that our value in front of x squared and y squared are not the same value. That only happens whenever you have a circle. So unfortunately, we're not going to be able to divide out. We are going to have to actually factor. We also know that, well, I'm going to have to complete the square twice. So let's go ahead and do the first step you would normally do anyway. And that is, let's group our x terms and our y terms together. And if I have anything that does not have an x or y on it, we want to make sure we move it to the other side. In this case, we already have our 44 over here. So I could divide everything by 4, and that's fine. That would actually get rid of a lot of the values that we need to worry about. But we still have a value in front of this x squared. So rather than dividing it out, let's just go ahead and factor it out like we normally would have done before. So I'm going to factor out a 16 here, leaving me with x squared plus 2x. And I'm going to factor out the 4 here, leaving me with y squared minus 2y. We know to complete the square, for our first one, we're going to take half of 2 and square that. So we're going to add 1, so that'll factor into x plus 1 squared. Now remember, when we added this 1 here, we really didn't add 1 to the problem. Because we had the 16 on the outside, we really added 16 times 1. So whenever I go to add on the other side here, I need to make sure that I add 16. Let's look at the next part for the y. We know that we have, to complete the square, we need to also add 1 because half of negative 2 squared is going to be 1. So we know this is going to factor into y minus 1 quantity squared. But again, remember, we didn't add 1 to the problem. We really added 4 times 1 to the problem. So I need to make sure that I add 4 on the other side. The biggest mistake I see people make when they do the ellipse for complete the square is they forget to add the value that's the correct value on the other side. So just be really careful, especially if you factor something out at the beginning. So let's simplify this. Now, this becomes just like the problem we looked at before. We know to be in the standard form of the ellipse, this value over here on the right needs to be, instead of 64, it needs to be equal to 1. So our last step must be that we have to divide everything by 64. And we notice again it works out nicely that 4 times 16 is 64, so simply we're going to have the quantity x plus 1 over 4 plus the quantity y minus 1 squared over 16 equals 1. And this would be the standard form of our ellipse. Notice that our value for a squared would be 16, our b squared would be 4. Let's say I give you some information about the ellipse and I want you to get the equation in the standard form. In order to solve a problem like this, we need to think about the values that we have and what they represent. They tell us that we have the center of the ellipse. Well, we know that's going to be HK. And we know that we've got a vertice at 0, negative 9. So this tells us that we had to add or subtract a value, in this case, to get a value of negative 9. So we know that when we're talking about the vertices, we're adding or subtracting a value of a. So let's say that k plus a is going to be negative 9. We know it doesn't really matter whether it's k plus a or k minus a, because we know that when we go to write our equation, all we're going to really care about is a squared. So regardless of the sign, it's going to be fine. Alright, so this tells us that h is going to be 0, and k is going to be 0. And a is going to be, whether you write 9 or negative 9, we're going to square it. So I'm just going to go ahead and write the positive value. So this could be the same thing as the k minus a. If you really want to look at it that way, that's perfectly fine. The other piece of information we know about is the minor axis. Well, what do we know about the minor axis? Well, we know that the minor axis is going to be a length of 2b. So this is really telling us that 2b is going to be 6 units long. This is really helpful because now we know that b is going to have to be 3. Last, we know that if we're going to write our equation, all we need are these things, h, k, a, and b. We could find c, but that really only helps us find the focus, and that's not what we need in this problem. So you can find c if you'd like to, but it's unnecessary for this problem. So let's start with what we know. We know the standard form is going to be x minus 0, or you could just write x squared, plus y minus 0, or just y squared, over something, and that's going to equal 1. Now, how do I know where the value for a squared and b squared is going to go underneath? It's all dependent on the vertex. We know the vertex is the major axis. Which coordinate did we change in the vertex? We changed the y coordinate. That means a squared is going to have to go under the y coordinate. So 81, or a squared, is going to have to go under the y value. That means that b is going to be, our minor axis is going to go underneath the x coordinate. So this is going to be 9. And again, you can leave this as x squared over 9 plus y squared over 81 equals 1. So remember that when we talk about our vertices, our vertex, whichever coordinate changes there is going to be where your major axis is. If for some reason instead of the vertices they gave us a covertice, remember that talks about the minor axis. So think about the coordinate that it goes with that. That's going to be your value that gives you B. So these are a couple examples. Here's a couple examples for you guys to try for homework. So copy down this information and find the standard form of the ellipse given that the center is 0, 0, a vertex is 0, negative 13, and a focus is at 0, negative 5. If you need to pause to get this down, go ahead and do this now. Here's another problem I'd like you to complete for homework. Again, find the equation of the ellipse in standard form, given that the center is at 0, 0, a vertex is at 17, 0, and a focus is at 8, 0. Feel free to pause if you need more time to get this down. Now let's look at one last example before I give you your last problem for homework. Let's say we're given a graph, and we need to write the equation of the ellipse given the following. Well, unlike our parabola, even though we don't have our focus and other things graphed, we can actually find the key points that we need. We know that we can look at this graph and we can see, oh, wow, my major axis is obviously going to be a vertical major axis, and I'm going to have a horizontal minor axis. I can also estimate the center pretty easily because I can kind of tell where the value of my vertices are going to be. Here's vertex 1. Oops. Here's vertex 2. And I know that my co-vertices are going to probably be over here at this largest part, so co-vertex 1 and co-vertex 2. And I know that if I was to draw the line between these two, where they intersect would give us our center. That's my supposedly straight line. So here's my center. This is our value of h and k. So negative 3 is my center. So h is going to be negative 3, and k is going to be negative 3. Now we know that this is our major axis right here. So the distance from here to here is going to be our value of a. Well, I've got 1, 2, 3, 4, 5, 6. So we know that a is going to be a length of 6. So half of my major axis is 6, and my major axis itself is 12. Then we know also that from co-vertex to center is going to be our distance of b. So we've got 1, 2, 3, 4. That tells me that b is going to be 4. Again, we don't need the value for c to find the equation of our ellipse. So we're done with everything we have here. So now we just need to go ahead and write our equation. So we know it's going to be x plus 3 squared over something plus y plus 3 squared over something equals 1. We know that a is 6 and we know that b is 4. But where does a squared go underneath? Does it go underneath the x coordinate or does it go underneath the y coordinate? Well, the answer to that is to look at where our vertices are. Which coordinate changed from our center to find our two vertices? Well, it's the y coordinate. So that tells me that a squared is going to have to go under the y coordinate. So this is going to be a squared, or 36. And this is going to be b squared, or 16. And here's the equation of my standard form for the ellipse that I have drawn here. Your last homework problem is to do a problem just like we did. Here's the graph. You don't have to sketch the graph, but definitely use the graph to help you find the equation of the ellipse in standard form. Feel free to pause it if you need to kind of take it and kind of count or figure out your values that you need here. When you're done pausing, go ahead and make sure you have these 3 problems completed for homework, so tomorrow in class when you come in, you'll have everything and we'll go over the correct answers.